Hello guys, welcome back. Now we will see IPv6 addressing. Already we have seen IPv4 addressing. Some persons are thinking IPv6 is updated version of IPv4, but it's wrong. IPv6 totally different from IPv4. And what is the difference between IPv4 and IPv6 we will see in the end of this chapter. Okay, so these 5 topics we will cover in this chapter. First is introduction of IPv6. Second is address space allocation. The third is global unicast addresses. The fourth is auto configuration, and the fifth is renumbering. Okay, so we will move on one by one. First, we will see introduction of IPv6. Already we know IPv4 dividing in 4 octets, or we can say 4 bytes. Okay, but IPv6 is 128 bits long, and we can say we are dividing 128 bits in 16 bytes, or otherwise we can say octet. Okay, so how we will write, like we have one bar. This is 128 bits. This is 128 bits. It's 128 bits long. This is IPv6 address, and something like this. Okay, so IPv6 is 128 bits long, and it has 16 bytes octet, and octet, otherwise we can say 16 bytes. Okay, so already we have seen in IPv4 have only 4 bytes and 4 octets, we can say. IPv6 is too long. Okay, so we will divide in some notations. Actually, we know all we know computer storing address in a binary form, but when humans are handling addresses, then they will divide in some notations. Okay, so let's move on notations. Notations have their own types. Notations. So we have 4 types of notations. First notation is dotted decimal notation. Second is colon hexadecimal. Third is mixed representation, and fourth is CITR notation. So first is dotted decimal notation. Already we have seen in IPv4 dotted decimal notation. In dotted decimal notation, how we are dividing over 128 bits. We are dividing over 128 bits. We are dividing over 128 bits in 16 bytes with dot. Okay, how? Let's see example. So this is the example of this is the example of this one is the example of dotted decimal notation. Here we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We divided in 16 bytes with dot. So this is dotted decimal notations. Dotted decimal notation in IPv6 we are using rarely because it's too long. Okay, now we will move on the second notation. The second notation is colon hexadecimal. Colon hexadecimal notations, what we are doing, we are dividing 128 bits in 8 sections. We are dividing 128 bits in 8 sections, and each section is 2 byte long. Okay, we can say like 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is 8. Okay, so we divided 128 bits in 8 sections. These are 8 sections, and we are saying each section is 2 byte long. Okay, and second thing, this is the first thing is we are dividing in 8 section. Second thing is each section have 2 byte, and now third thing we are saying every hexa notations having each hexa notation having 4 hexadecimal digits. Means if we are saying, then we obviously we will have here 4 hexadecimal digits. Okay, and this section's having 32 bits. Okay, so let's see one example. So this is the example. Like here we can say we divided in 8 sections. Already we said in colon hexadecimal. Why we are using colon hexadecimal? For making our address more readable. Okay, so this is first section, this is second section, this is third section, fourth, fifth, sixth, seven, eight. We divided in 8 section, and each section have 2 bytes long, and each section have 4 hexadecimal digit. Okay, so this is the colon hexadecimal notation. Now here we can see one thing, like obviously it is also too long. Then if sometimes like we have number of zeros present in our address, then what we can do, we can use abbreviation there. Abbreviation we can say, and abbreviation we can call zero compression also. Like for example, I have here 7, here I can say 0074. Then how I will compress this zero compression, how I will use here, I will write only 74. It is automatically considered like here 2 zeros are present. Then I can write like this 74. If I have 0000, then I can write 0 zeros only 0. This is zero comparison. If somewhere I have like 36 0, then I can't compress this 1 0. If we have all zeros, then we can compress like this. If we have 2 zeros, then we can compress like this. So here we can use zero comparison also. And this is the one example here. We can see we have number here. We have written like 000. That means we have here 4 zeros. Here 4 0, here 4 0, and here 4 0. This is zero comparison form. Okay. Now I wanna compress this 000 in like short form. Then what can I use? I can use double semicolon here. For example, how I can do this? Double semicolon BBF 0 F F F. Here I reduce this, I compress the zeros with double semicolon. Double semicolon means what is this representing? It is representing like we have 3 times zeros here. Okay. Now here one thing you can see, we have 0 here also. Here also you will say here also we can use double columns, double semicolons, but we can use zero comparison or double semicolon only once. Once we can use zero comparison, zero compression. Only one time we can use zero comparison, and only one time we can use double semicolon. Okay, so this is all about colon hexadecimal. Okay, now we will move on our next notation. Next notation is mixed representation. Mixed representation means we have 2 notations. We are mixing that. First notation is colon hexadecimal. The second is dotted decimal notation. When this problem will occur, or when this situation will come, if we are embedded IPv4 in IPv6 address, at the time this situation will come, and there we will use mixed representation. Here this is the example. We can see Here up to 6 sections we used only colon hexadecimal, and remaining 2 sections we used dotted decimal, or here colon hexadecimal. This is IPv4 address and this is IPv6 address. So this is the condition where we can use IPv6 in colon hexadecimal with IPv4 dotted decimal. And one situation also occur here, if you think like these all are zeros. If these all are zeros, there also we can use 0 double semicolon 130 dot 24 dot 24 dot 18. So like this also we can write this. So this is mixed representation. Now the last in the fourth notation, that is CIDR notation. CIDR notation, we know IPv6 addresses allow IPv6 address is using hierarchical addresses. Okay, for this reason IPv6 allows the classless addresses or CIDR notation. Okay, so CIDR notations where we are using, if we wanna represent, or if we wanna show prefix of 60 bits, then we can use CIDR notation there. What is the mean? This is the example. This is the one example. Here we can see this is 60-bit prefix representation. 60-bit prefix representation using CIDR notation. This is the 60-bit prefix representation using CIDR notation. What is prefix and suffix? We will see further how we can classify a prefix and suffix. So in what CIDR notations is showing, in CIDR notations we can use prefix. We can show prefix of bits. Okay. So now we will see one question. Already we have seen notations. First we have seen dotted decimal notation. After that we have seen colon hexadecimal notation. After that we have seen mixed representation, and the last we have seen CIDR notation. So this is one question. An address with 64 zeros followed by 64 ones. We have to write colon hexadecimal address for this. So how we will write? Let's say 64 zeros. So first we will write 64 zeros, and remaining 64 ones. 64 ones, then we can say FFF, FFFF, F F F F F F F. So this is the colon hexadecimal notation. Okay. So like this we can convert this in dotted decimal notation also. We can use mixed representation also. Okay. So colon hexadecimal. Now here we have zeros. Then we can use zero comparison also. Then how we will use? We will use like this. F F F F semicolon. We have seen how we are using zero comparison. Okay. So it's easy. F F F. So we can use like this. Okay. So I hope you understand all notations, how we are classifying our addresses in notations. Okay, now we will move on next topic.